Hello students, here is the first question. Find the position vector of the point R divides the line joining 2 points P and Q whose position vectors are I plus 2j minus k and minus I plus j plus k respectively in the ratio 2:1. So in this question, the point R dividing the line segment PQ in the ratio 2:1, and we need to find the position vector of this point R when it divides PQ internally in the ratio 2:1, and also we need to find the position vector of the same point when it divides externally in the ratio 2:1. The important question, this question asked in the year March 2017. See here, when the question includes internally case and externally case, ನಿಮ್ಮ ತಲೆಯಲ್ಲಿ ಬಂದ್ಬಿಡ್ಬೇಕು, this problem is based on the section formula. So see here first question is we need to identify the position vector of the point R when it divides PQ segment internally case, when it divides PQ internally in the ratio m is to n, internally in the ratio m is to n, m is to n. Here m is to n, he has given that 2:1. So it means value of m is 2 and n is 1. So therefore, position vector of the point R is OR vector, and which formula is given by MB vector plus NA vector divided by M plus N. Now observe here, in this question, A vector is a position vector of the first point, that is what, P point, whose position vector is I plus 2j minus k. Therefore, A vector is equals to I plus 2j minus k, and B vector is a position vector of the second point, that is Q, and whose position vector is B vector. So B vector is equals to minus I plus j plus k. Just substitute the A vector, B vector and value of M and N, the position vector of the point R, we got the required answer. So see here, OR vector is equals to M into B vector. Value of M is 2 into B vector minus I plus j plus k plus N, value of N is 1 into A vector. A vector is I plus 2j minus k divided by M plus N, means 2 plus 1. Therefore, OR vector is equals to 2 into minus I minus 2i, 2 into j 2j, 2 into k 2k. Similarly, plus 1 into I plus I, and then plus 1 into 2j, plus 1 into minus k is minus k, divided by 2 plus 1 is 3. Therefore, position vector of the point R, OR vector is equals to minus 2i plus I is equals to minus I, 2j plus 2j equal to 4j, 2k minus k is equals to k divided by 3. Hence, position vector of the point R when it divides PQ internally in the ratio 2:1 is minus 1 by 3 I cap plus 4 by 3 j cap plus 1 by 3 k cap. I hope all of you understood the first case. And also we need to identify position vector of the same point when it divides PQ externally in the ratio 2:1. And the formula for externally case is OR vector is equals to M into B vector minus N into A vector divided by M minus N. Just substitute A vector, B vector and values of M and N in this formula. So therefore, position vector of the point R, OR vector is equals to value of M is 2 into B vector. B vector is minus I plus j plus k minus n is 1. So minus 1 into A vector I plus 2j minus k divided by M minus n, means 2 minus 1. Therefore, OR vector is equals to, 2 into minus I minus 2i, 2 into j 2j, 2 into k 2k, minus 1 into I minus 1 into 2j minus 2j, minus 1 into minus k is plus k, divided by 2 minus 1 is 1. Therefore, OR vector is equals to minus 2i minus I is minus 3i, 2j minus 2j is 0j, 2k plus k is 3k divided by 1. So therefore, position vector of the point R when it divides PQ externally in the ratio 2:1 is minus 3i plus 3k. I hope all of you understood one of the important question. So let's start the next question. If two vectors a vector and b vector such that magnitude of a vector is equals to 2, magnitude of b vector is equals to 3 and a vector dot b vector is equals to 4, then find the value of magnitude of a vector minus b vector. So this is also one of the important question asked in the year July 2014. So see here he has given that magnitude of a vector, magnitude of b vector and a vector dot b vector. So we need to identify the value of magnitude of a vector minus b vector. So see here, just consider one of the identity which consists all these quantities. So which is what? We know that magnitude of a vector minus b vector whole square is equals to magnitude of a vector square plus magnitude of b vector square minus 2 into a vector dot b vector. In this formula, just substitute the given values. So magnitude of a vector minus b vector whole square is equals to magnitude of a vector is 2, so therefore 2 square plus magnitude of b vector is 3, 3 square minus 2 into a vector dot b vector is 4, so 2 into 4, which is equals to 2 square is 4 plus 3 square is 9 minus 2 into 4 is 8. Hence 4 plus 9 is 13, 13 minus 8. So finally magnitude of a vector minus b vector whole square is equals to 5. But we need magnitude of a vector minus b vector. Hence magnitude of a vector minus b vector is equals to square root of 5, and which is the required answer. I hope all of you understood. Let's start the next question. And the next question is, find a unit vector perpendicular to each of the vectors a vector plus b vector and a vector minus b vector, where a vector is equals to 3i plus 2j plus 2k and b vector is equals to i plus 2j minus k. One of the most important question. So these questions will be asked for 3 marks in your annual examination, and this question asked in the year March 2020. Not only one time, this question asked many times in your annual examination. So here we need to identify the unit vector perpendicular to both a vector plus b vector and a vector minus b vector. So let's say c vector is equals to a vector plus b vector, which is equals to, see here, a vector plus b vector 3i plus i 4i, 2j plus 2j 4j, 2k minus 2k 0k. And similarly, let b vector is equals to a vector minus b vector, and a vector minus b vector 3i minus i is equals to 2i, 2j minus 2j 0j, 2k minus into minus plus, so 2k plus 2k is 4k. And now we need to identify the unit vector perpendicular to both of these two vectors, c vector and d vector. So, and we know that the formula which is perpendicular to both c vector and d vector is c vector cross d vector. And the unit vector along this vector is n cap, which is equals to c vector cross d vector divided by magnitude of c vector cross d vector. The required unit vector is c vector cross d vector divided by magnitude of the c vector cross d vector. See here we need to identify cross product of c vector and d vector. And as you know that cross product of two vectors is obtained by the determinant method. So let's say c vector cross d vector is equals to determinant of, first row is the unit vectors I, j and k. Second row is coefficient of I, j, k in c vector, that is 4, 4, 0, 4, 4, 0. And third row is coefficient of I, j, k in second vector, 2, 0, 4, 2, 0, 4. Therefore, c vector cross d vector is equals to, therefore, c vector cross d vector is equals to, method of solving the determinant, plus, minus, plus. So, I into deleting first row, first column, 4 into 4, 16, minus 0 into 0, 0, minus j into deleting first row, second column, 4 into 4, 16, minus 2 into 0, 0, plus k into, deleting first row, third column, 4 into 0, 0, minus 2 into 4 is 8. Hence, C vector cross D vector is equals to 16I minus 16J plus into minus minus 8K. So, which is a cross product of two vectors C and D. And also we need the magnitude of C vector cross D vector. Therefore, magnitude of the vector C vector cross D vector. Magnitude of C vector cross D vector is equals to square of the I coefficient, that is 16 square. 16 square is 256 plus square of the J coefficient, that is minus 16 square, which is equals to 256 plus square of K coefficient, that is minus 8 square, which is equals to 64. Hence, magnitude of C vector cross D vector is equals to square root of, observe here, 256 plus 256 is 512, 512 plus 64 is 576, 576, and square root of 576 is 24. Therefore, required unit vector n cap, that is equation 1 implies, required unit vector is equals to required unit vector n cap is equals to C vector cross D vector, that is what, 16I minus 16J minus 8K divided by 24. Therefore, n cap is equals to, 16 divided by 24 I cap minus 16 divided by 24 J cap minus 8 divided by 24 K cap. Hence, the final required unit vector n cap is equals to 8 2s are 16, 8 3s are 24 I cap minus 8 2s are 8 3s are minus 8 1s are 8 3s are. So, therefore, required unit vector which is perpendicular to C vector and D vector is 2 by 3 I cap minus 2 by 3 J cap minus 1 by 3 K cap. I hope all of you understood. Let's start the next question. And the next question is, if A vector equals to 2I plus 2j plus 3k and B vector equals to minus I plus 2j plus k and C vector equals to 3I plus j are such that A vector plus lambda times of B vector is perpendicular to C vector, then the value of lambda. So, one of the most important question. So, this question asked many times in your annual examination. So, I wrote once here, March 2014. Here in this question he has given that A vector plus lambda times of B vector, A vector plus lambda times of B vector is perpendicular to the C vector. So, this is a given information in this question, and we need to identify the value of lambda here. And we know that if any two vectors are perpendicular to each other, then the dot product is 0. It means dot product of A vector plus lambda times of B vector and C vector is equals to 0. So, now substitute the values of A vector, B vector and C vector in this equation. So, here A vector is 2I plus 2J plus 3K plus lambda times of B vector. B vector is minus I plus 2j plus k dot C vector. C vector is 3I plus j plus 0k, which is equals to 0. Now, see here, we need to simplify this to find the value of lambda. First thing, 2I plus 2j plus 3k as it is, then plus lambda into minus lambda I plus 2 lambda j plus lambda k dot 3I plus j plus 0k is equals to 0. Now, see here in the first term, 2I minus lambda I can be written as 2 minus lambda I cap. Similarly, 2j plus 2 lambda j can be written as 2 plus 2 lambda j. Similarly, 3k plus lambda k can be written as 3 plus lambda k dot 3I plus j plus 0k is equals to 0. Now observe here, first vector is in a ijk form and second vector is also in ijk form. So we need to find the dot product of these two vectors. And we know that dot product of two vectors is obtained by multiplying the corresponding coefficients I with I, j with j and k with k. So in the first vector, coefficient of I is 2 minus lambda. In second vector, coefficient of I is 3. So therefore 2 minus lambda into 3, 2 minus lambda into 3. Here plus 2 plus 2 lambda into 1, coefficient of z in the first vector 2 plus 2 lambda and coefficient of z in second vector is 1, plus 3 plus lambda into 0, which is equals to 0. Now observe here, 2 into 3 6 minus lambda into 3 3 lambda plus 2 into 1 2 2 lambda into 1 2 lambda plus 3 plus lambda into 0 is 0, equal to 0. Now see here, by this equation 6 plus 2 is equals to 8 and then minus 3 lambda plus 2 lambda is equals to minus lambda, which is equals to 0. So for value of lambda, shift this lambda to right side, it becomes value of lambda is equals to 8, and which is the required value. I hope all of you understood. Let's start the next question. And the next question is, three vectors a vector, b vector and c vector satisfies the condition a vector plus b vector plus c vector is equals to 0 vector. Evaluate mu equals to a vector dot b vector plus b vector dot c vector plus c vector dot a vector if magnitude of a vector is 1, magnitude of b vector is 4 and magnitude of c vector is 2. So in this question, he has given that magnitude of a vector, magnitude of b vector, and magnitude of c vector, and also a vector plus b vector plus c vector is equals to 0 vector. So we need to calculate the value of mu here, where mu is equals to a vector dot b vector plus b vector dot c vector plus c vector dot a vector. So one of the important question. This question asked in the year March 2017. So observe here, in this question, he has given that a vector plus b vector plus c vector is equals to 0 vector. So to identify the value of mu, ನಾನೇನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನೋಡ್ರಿ, multiply both side by a vector plus b vector plus c vector dot a vector plus b vector plus c vector equals to 0 vector dot a vector plus b vector plus c vector. I hope all of you understanding. Now see here, we know that a vector dot a vector is equals to magnitude of the vector a square. By using this, see here, a vector plus b vector plus c vector dot a vector plus b vector plus c vector can be written as magnitude of a vector plus b vector plus c vector whole square equal to 0 vector dot value of a vector plus b vector plus c vector is 0 vector. So 0 vector. I hope all of you understood. Now see here, by using the algebraic formula a plus b plus c whole square, magnitude of a vector plus b vector plus c vector whole square can be written as magnitude of vector a square plus magnitude of vector b square plus magnitude of vector c square plus 2 into a vector dot b vector plus 2 into b vector dot c vector plus 2 into c vector dot a vector is equals to 0 vector dot 0 vector is magnitude of the 0 vector square. I hope all of you understanding. Now sir, in the question he has given that magnitude of a vector is 1, so 1 square, plus magnitude of b vector is 4, 4 square, plus magnitude of c vector is 2, 2 square. Plus in these three terms, we can take 2 as a common, remaining a vector dot b vector plus b vector dot c vector plus c vector dot a vector is equals to magnitude of 0 vector is 0, so 0 square. I hope all of you understanding. So 1 square is 1 plus 4 square is 16 plus 2 square is 4 plus 2 into. Observe here, in this question already he has given that a vector dot b vector plus b vector dot c vector plus c vector dot a vector is equals to mu. So therefore this thing is replaced by the mu, which is equals to 0. Observe here, in this entire equation the unknown thing is mu. So by simplifying this equation, we got the required value, that is what, mu. So 16 plus 4 is 20, 20 plus 1 is 21 plus 2 mu equals to 0. Hence 2 mu is equals to minus 21. Therefore, mu is equals to minus 21 by 2 is the required answer. I hope all of you understood. Let's start the next question. And the next question is, if A vector, B vector and C vector are unit vectors such that A vector plus B vector plus C vector is equals to 0 vector, find the value of A vector dot B vector plus B vector dot C vector plus C vector dot A vector. So this question is similar to previous one. In this question also he has given that magnitude of A vector, magnitude of B vector, magnitude of C vector. That is what one unit, because these three given vectors are unit vectors. And he also given that given three vectors are satisfies the equation A vector plus B vector plus C vector is equals to 0 vector. And we need to calculate the value of A vector dot B vector plus B vector dot C vector plus C vector dot A vector, which is already calculated in the previous question. So here again same thing. In this question he has given that A vector, B vector and C vectors are a unit vector. It means that magnitude of A vector is equals to magnitude of B vector is equals to magnitude of C vector is equals to 1. And also he has given that these three vectors satisfies the equation A vector plus B vector plus C vector is equals to 0 vector. And to identify the required quantity, first I am going to multiply on both sides by using A vector plus B vector plus C vector. So multiply by what? A vector plus B vector plus C vector dot A vector plus B vector plus C vector equal to 0 vector dot A vector plus B vector plus C vector. I hope all of you understanding. Again by using the A vector dot A vector is equals to magnitude of A vector. So therefore, A vector plus B vector plus C vector dot A vector plus B vector plus C vector is equals to magnitude of A vector plus B vector plus C vector whole square is equals to 0 vector. Value of A vector plus B vector plus C vector is equals to 0 vector. By using the algebraic formula, magnitude of A vector plus B vector plus C vector whole square is equals to magnitude of vector A square plus magnitude of vector B square plus magnitude of vector C square plus 2 into A vector dot B vector plus 2 into B vector dot C vector plus 2 into C vector dot A vector is equals to 0 vector dot 0 vector is equals to magnitude of 0 vector square. I hope all of you understanding. Now see here in this question he has given that magnitude of three vectors is equals to 1. Therefore 1 square plus 1 square plus 1 square plus in these three remaining terms we can take 2 as a common. So 2 into A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equals to magnitude of 0 vector is 0. I hope all of you understanding. So we need this quantity A vector dot B vector plus B vector dot C vector plus C vector dot A vector. So therefore in next step I can simplify this 1 square plus 1 square plus 1 square is equals to 3 plus 2 into A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equals to 0 square is 0. Now see here we need the quantity. We need the quantity A vector dot B vector plus B vector dot C vector plus C vector dot A vector. So for that I shift this 3 to right side. It becomes 2 into A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equals to plus 3 becomes what? Minus 3. Then the required quantity A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equals to minus 3 by 2. I hope all of you understood. Let's start the next question. And the next question is, see here, this is one of the most important question asked in your annual examination for many times. So this is a proof of section formula for the internally case. For the internally case. See here, in this question he has given that show that position vector of the point P which divides the line joining the points A and B having position vectors A vector and B vector internally in the ratio m is to n is m into B vector plus n into A vector divided by m plus n. See here, in this question he has given point P dividing the line segment AB. So let's see here, this is a line segment AB, and this line segment dividing by the point P in the ratio m is to n, in the ratio m is to n, and we need to prove the position vector of this point, that is what, OP vector. That is what, OP vector is equals to what, m into b vector plus n into a vector divided by m plus n. And also he has given that position vector of the point A is a vector and position vector of the point B is b vector. So see here, position vector of the point A is a vector and position vector of the point B is OB vector, that is what, b vector. Now we need to prove that OP vector, let's say it is equals to R vector. So we need to prove that R vector is equals to m into b vector plus n into a vector divided by m plus n. Now see here, by using this figure, magnitude of this AP is m and magnitude of this PB is n. So by using this diagram, I can write AP divided by PB is equals to m divided by n. Now by the cross multiplication, n into AP vector is equals to m into PB vector. I hope all of you are understanding. Now see here, n into AP vector is a vector joining 2 points P and A. Therefore, AP vector can be written as position vector of the terminal point OP vector minus position vector of the initial point OA vector equal to m into PB vector can be written as OB vector minus OP vector. I hope all of you are understanding. Now see here, in this question already he has given that n into minus OA vector is A vector equal to m into OB vector is B vector, and we defined position vector of the point P is R vector. So OP vector is R vector minus R vector. I hope all of you are understanding. Now we need the position vector of the point P, that is what, OP vector, which is R vector. So therefore, by the rule of multiplication, n into R vector minus n into A vector equal to m into B vector minus m into R vector. So for the vector R, shift R vector on one side of the equality sign. It becomes n into R vector. Shift this minus mr vector to left. It becomes plus mr vector equals to m into B vector. Shift this minus na vector to right. It becomes plus na vector. I hope all of you are understanding. Now in between these two, I can take R vector as a common. R vector is common, remaining m plus n equal to m into B vector plus n into A vector. Therefore, R vector is equals to mb vector plus na vector divided by m plus n, and which is our required proof. That is what, position vector of the point P is mb vector plus na vector divided by m plus n. I hope all of you understood. This is the most important question, many times asked in your annual examination for 3 marks.